Welcome to Building 9 here at the Johnson Space Center, the Space Vehicle Mockup facility. And we've actually got behind us a Space Vehicle Mockup, our Space Exploration Vehicle, one of our rovers, which is this week being used for the dry runs of the Research and Technology Studies Test, or RATS. And here to talk with us today, we have James Johnson, who is the test director for RATS. Thanks so much for coming and talking with us.
Well, thank you, Brandi. I appreciate it.
So what's going on this week?
Well, as you mentioned, it's a dry run, and so what we mean by dry run is really practice. Practice makes perfect for us. We're getting ready for our test, which is going to be towards the end of August. Our official testing actually starts August 20th, and we're going to run for 10 days straight. So what we're trying to do right now is exercise some of the communication systems, data systems, the big simulation, and the vehicle that's behind me. Trying to get all of that up and running, train the crew, and be all ready to go come the end of August. So that's what we're doing.
And let's back up a little bit. What is RATS exactly?
So RATS is Research and Technology Studies, as you mentioned, and what that does is we analyze both architectures, mission architectures, how you're going to conduct a space mission going to an asteroid, going onto Mars, going back to the moon, wherever we may go outside of low Earth orbit, and then the technology piece, and that's actually trying to mature and advance new and developing technologies. So we're actually hoping to do both coming up here later on this month.
And this is part of our analogs program, right? It's simulations here on the ground, right?
Exactly. Analogs is all about exercising real-time mission operations with new and developing technologies, so that way we can get a good understanding of how some of these technologies are going to perform when we actually go ahead and take them beyond low Earth orbit. Okay. We do that early in development, so that way there's fewer surprises when we actually get there.
Okay. And folks who watch NASA TV a lot may have seen fairly recently the NEMO mission down below the sea, another one of our analogs, and we also had one just last month in Hawaii doing some in situ resource utilization work. So we've got a lot of different things going on, but what we're trying to accomplish specifically with this year's RATS test?
So this year's RATS, there's two aspects that we're really taking a look at. The first is, again, that architecture piece. And what we're looking at there is where do we put crew members between some of the major elements for deep space exploration, okay? We have the multi-mission space exploration vehicle here. We also have what would be called the deep space habitat, and we're mocking that up with the workstation also here in Building 9 in another room. And we're trying to understand, you know, how many crew do you want in each of those elements as you're actively exploring a surface. And in this case, it's actually an asteroid surface. We're looking at the surface of Itokawa.
Okay. So. And you know, I guess, and we've had many RATS tests in the past. Usually, though, we have desert in front of the RATS, desert RATS.
Right.
This year, though, we're here in Houston at Johnson Space Center. Why is that?
Well, there are a few different reasons for it. What we really want to do is make sure we're testing in the best environment to get as much data as we possibly can for those future architectural scenarios. And the desert doesn't really lend itself well to an asteroid surface. You know, that's a microgravity environment. So with the NEMO test, we ended up focusing a little bit more on the microgravity aspects. And for the actual exploration aspects, we found we can do a lot of that through simulation. And that's why we're here utilizing the simulation behind us.
Okay. And you mentioned, like you said, this the SEV, the Space Exploration Vehicle behind us, is one of the ways, and we've got a few others. You mentioned the Deep Space Habitat. It all comes together and hopefully will help us figure out how we're going to send humans to an asteroid in the future?
Exactly. Yeah, we want to understand how we're going to do it. We want to understand the technologies that are going to take us there. So, you know, the other piece is that technology studies, and one neat thing that we're doing at RATS this year is we're actually demonstrating some new generation fuel cell technologies. So we actually will have a fuel cell coming in here periodically and providing power to the space exploration vehicle. And then as they're providing that power, fuel cell is going to provide power. It also produces a lot of water in that process. And that water is going to get taken to another facility here on site to exercise another technology called Marco Polo, and that's a demonstration technology for electrolysis of water, breaking down the water, turn it into hydrogen and oxygen, assuming that that water was actually gathered through in situ resource utilization.
Okay.
So that way we're testing out a couple of different technology pieces while we're answering some of the questions of how we're going to explore an asteroid.
And hopefully all this comes together and you've got kind of a big piece of the exploration puzzle solved by the time we're ready to go, right?
Exactly. What we do is we call that the ops concept. And what we try to do is define how are you going to do those operations, how are you going to conduct that mission, so that way as you are developing your hardware, everybody is in lockstep with how you're going to develop the hardware, why you're developing it, what the core needs and goals and objectives are for that hardware. So that way when it's all built and ready to go, everybody's in full agreement, and we expect how that is going to behave when we take it out to low Earth orbit.
Okay. And you know, I think a lot of people are talking about the Curiosity landing that's coming up on Mars well, next week, at the beginning of next week. Do you think, you know, hopefully someday we'll be sending humans to follow it. Do you think these are lessons that we'll be able to use when it's time for that?
Oh, certainly. You know, the question of where do you place crew between some of the deep space elements is one that is not unique just to asteroid exploration. It applies to Mars, it applies to lunar exploration, any destination we go. How do you really handle those types of operations? Where do you place the crew? How are they best utilized? Those questions are going to apply even when we go to Mars. And so hopefully the lessons that we learn here, we'll be able to go ahead and apply when we actually set foot on Mars.
Okay, maybe we'll come back and talk more about that when that happens too.
I hope I can be here for that.
Absolutely.